All right, this is Honors Algebra 2 Pre-Calc, and we are doing 3.5 in Algebra 2, which is a concept called linear programming. So I'm going to first throw out there that linear programming is not a thing you are going to do without a computer or a calculator. We're going to walk through this, but I'm going to throw out there that this is one of the more tedious sections we do, just because graphing these things by hand is not an effective way to solve these problems. So we're going to use the calculator as well. But please try not to get frustrated. You're not going to see a whole lot of linear programming questions on any of my exams, but I want to introduce you to the concept. Linear programming is a means to solve, to find the best possible solutions to complicated situations that have a lot of what we call constraints. So I'm going to read you an example using farming, and we're going to walk through a bunch of farming stuff in this particular section because that's the example they chose to use. So Max Desmond is a farmer who plants corn and wheat. In making planting decisions, he used the 1996 statistics it right from the United States Bureau of the Census. Keep in mind, 1996 is before most of you, nope, all of you were born, before all of you were born. So I get that this is a long time ago, but the same kind of concept holds true. So there's this table for a bunch of different crops, right? Corn, soybeans, wheat, cotton, rice. Notice that the yield per acre, so acre is a unit of land, it's a measurement of area. Yield per acre means how much of that crop you get for an acre, right? So if you plant a whole acre and you only get a small yield, that would not be a very good crop to make money. BU stands for bushel, which is one way that things are gathered, like corn is gathered in bushels and so are soybeans and wheat. Okay, the last column of that table tells you how much money you get for that unit of what's gathered, right? So for example, corn is, if you notice, a very good crop to use in terms of how much you get per acre, right? You get a large yield per acre, but you get less money per bushel for corn than you do for, let's say, soybeans, right? So Mr. Desmond wants to plant according to the following constraints. So constraints are rules in place for whatever reason. Maybe in the real world it's because of some sort of a city ordinance that you can only plant so much of a certain type of crop within your land. Maybe it's because certain crops deplete the soil in some ways, and so you need to rotate your crops to put other kinds of crops in the soil over time, right? That's a pretty common thing, is that you have to rotate crops so that soil doesn't get depleted. Maybe there's some other reason, but it is what it is. So the first constraint, no more than 120 acres of corn and wheat. Now that probably means that he only has 120 acres to plant. And that's a pretty big property. 120 acres is a big property, and he's planting that much corn and wheat total. At least 20 and no more than 80 acres of corn, and at least 30 acres of wheat. Cool. So the question we're going to answer in example 2 is how many acres of each crop should Mr. Desmond plant to maximize the revenue, meaning the money he brings in from his harvest. So what we're going to do is use this thing called linear programming. So linear programming is used to find optimal solutions, meaning the best possible solutions. It comes from the Latin optimus, which means best. For the record, Optimus Prime literally means best first, so that transformer is dope. All right, so for instance, optimal solution for Mr. Desmond is finding the maximum profit, right? Optimal usually means something like maximum or minimum of something, the best or the most or least of something. So if, for instance, you're trying to make money, you would want the most, but if you were trying to, I don't know, trying to conserve your costs, if you're running a business and you want to talk about cost, well, then you would want minimum cost, right? Linear programming problems have the following characteristics. So these constraints, right, that we mentioned up here, right, constraints right here, those are going to be written as inequalities. The solution to the set of constraints, the shaded region that we're going to talk about, is called the feasible region. And you might pick that up that I accidentally, not accidentally, but I inadvertently called our shaded region the feasible region when we were doing 3.4 and doing systems of inequalities. And that was because this was coming up, but you hadn't heard the term yet. And lastly, the function that we are trying to maximize or minimize, the function that we want to make the most or least, is called the objective function. So I took this directly out of page 187 in your book because it was a fair amount of typing and it wasn't worth retyping it. So you'll find this on page 187 of your book if you need to revisit it. I'm going to pull up the relevant parts of the table as we walk through some examples. You will see that in this section I lean a lot more heavily on the book because it's a very wordy situation. We all know my handwriting is that of a child. So moving on. So, example 1, referring to the problem that we just read about Mr. Desmond, right? We're going to write a system of inequalities to represent the constraints. We're going to graph the feasible region, and we're going to write an objective function for the harvest. Okay, so let's start with the first of these things, which is we need a system of inequalities. So I need variables. typically we're going to use X and Y. Because they mentioned corn first, I'm going to use X for acres of corn. So I'm going to assign my variables, right? So X is acres of, that's not how you spell acres. I mean, it is. It just looks like a C, of corn, right? And I'm going to use Y to be my acres of wheat. And I generally just use X for the first thing that's mentioned in a problem and Y for the second because that's easier. So the first part of my inequalities is actually going to include two things that are not listed here, okay? So what I want you to notice about corn and wheat is that it doesn't make sense to plant negative corn and wheat, right? So when I make my system of constraints, right, so in A, I'm asked for my system of constraints. So let's go ahead and make these first, okay? So no more than 120 acres of corn and wheat. Well, corn and wheat, sorry, didn't mean to touch the paper, all right? So, so corn and wheat, number one, corn and wheat together would be X plus Y, and that's supposed to be no more than 120 acres. So that's going to be less than or equal to 120. It can be 120, but it can't be more than 120. Second thing, at least 20 and no more than 80 acres of corn. Well, that's going to be a compound inequality. That's going to say that corn, which was my X, is as low as 20 and as high as 80, right? And then at least 30 acres of wheat. So that's going to say that my wheat, which is my Y, has to be greater than or equal to 30. Now, I would note that these cover, excuse me, these cover X is greater than or equal to 0 and Y is greater than or equal to 0, which would be logical constraints. So those would be logical constraints. I would normally need to include those, okay? So if these statements didn't already cover that, I would want to include that it only makes sense to be in quadrant 1. The short answer here is that in most word problems, right, in most word problems, only quadrant 1 makes sense, right? Because in most word problems, my variables represent physical quantities that can't be negative. Now, there are exceptions to that. Sometimes the quantity, one of them is temperature, and temperature can absolutely be negative, as any cold winter will tell you. But just throwing that out there. So these are my 3 constraints. These are the 3 constraints that I'm going to use. Now, I'm going to need to graph those 3 constraints, right? And technically, it's 4 constraints because number 2 is actually 2 sides, right? It's between 20 and 80. So this is actually 2 different constraints, right? 20 on one side and 80 on the other. Second thing I'm asked to do is graph this. And we're going to graph it, but I'm going to cheat. So I'm going to solve to graph it, and then I'm going to cheat and use the graph that's in the book because, again, my handwriting is that of a child. So when I go to graph number 1, I'm going to solve for Y and get Y is less than or equal to negative X plus 120, right? 2 is actually going to be 2 lines, right? It's that X has to be between 20 and 80 inclusive, meaning you can include the ends. And 3 is that Y is greater than or equal to 30. So when I graph these, and we're going to need these pieces of information in a minute. So I'm going to move them down here. We won't actually need that one anymore, but we're definitely going to need this guy. So let's just move him down here. Okay, cool. We're going to need those constraints when we go ahead and talk about maximizing our profit. So when we go to find our graph, here's our graph. Okay, oh, my bad. Scrolling up for you. All right, so notice that they chose to go by tens, which is a smart choice because you don't really want to have to go up by 120 on your graph, right? So let's see what we see about this graph right here. So starters, let's do these guys, okay? So X is between 20 and 80. Well, that looks like this, right? That looks like this. Here's X is 20. Here's X is 80. X has to be between them. That's why it's the middle area, right? That fits. Here, Y is greater than 30. Well, here's where Y is 30, right? Y is 30. It's supposed to be above that, so that fits. And then this is the last one, right, in purple. This says start at 120, which would be, for the record, right here, right? And then go down 1, right 1, down 1, right 1. And then sure enough, that's my line, right? So that's my purple line. So this is my feasible region, right? This blue section is what we call a feasible region. And we're going to use that feasible region in example 2 to find a solution. But that's what this graph would look like. Notice in a word problem like this, it's going to make a lot more sense to pick a better scale for your graph. If you've got everything in tens, please go by tens or 20s. It makes a lot more sense. Notice that because this is a word problem, the axes are labeled. My x was acres of corn, so sure enough, the x-axis says acres of corn. My y was acres of wheat, so the y-axis says acres of wheat, right? These points, these corner points, are going to matter. We're going to talk about them in a minute, but before we do that, let's go ahead and do the third part of example 1, which is writing the objective function. So the objective function is the thing that you want to maximize, right, or minimize, right, in this case, or in minimize in other cases. In this case, we're maximizing. So let's look at this piece of information here. So there had to be a reason that we were given this information, and this is how much money he can make, right? So we're going to go ahead and write an objective function. So this is my part B, right? This is my graph. My part C is the objective function. So remember, C is going to be revenue. Now I'm going to use R to equal revenue. Revenue means how much money you bring in, right? It doesn't account for costs that you pay. This profit is your revenue minus your cost, or your income minus your cost. You could call revenue income. So what this is going to look like is revenue is going to be a function of two things, x and y. So instead of saying r of x, we're going to say r of x comma y, meaning it's a function of both of these things, right? So when I make my objective function, right, I need the money from corn plus the money from wheat. So let's think about what this money is going to look like. So I know that corn is X acres, right? Well, I make 113.5 bushels per acre. So this is going to be X acres, right? So X acres, which was in acres, right? Actually, we're going to call this the money from corn, and I'm going to show you how the units would work, and then we'll put it in our equation. So this is basically unit conversion, right? So I want to turn the X acres into money. So I have X acres, but I know that I get 113.5 bushels per acre, right? So if you've had chemistry at all yet, this is going to cancel the acres. And I know that for corn, I make 315 per bushel, which is going to cancel bushels. So what's going to happen is that my income for corn is going to be 3.5 times 113.5 times x. And honestly, if you don't want to simplify it, you could just write it that way. That's fine. If you want to multiply it, you can. You're going to get that it's 357.525x. But if you wanted to just write it this way, I wouldn't begrudge you that. That's not wrong, right? You're going to end up typing this in a calculator, to be honest, anyway. So if you just wanted to make this 315 times the 113.5 times x, that's not wrong, right? When I do the same thing for y, I think you can see the same logic for y, right? If I try to do the same thing for y, let's get rid of these guys that we don't need now. If I do the same thing for y, what you're going to find is that my money for wheat, right, my money for wheat is going to be my y acres times the 3.58 bushels per acre, which is going to cancel acres, times the $4.45 per bushel, which is going to get rid of bushel. So I'm going to find that this is 4.45 times the 35.8 times the y, right? And that's going to be my objective function. So we haven't talked about what we're going to have to do with that yet, but my objective function is going to be the money from corn plus the money from wheat, right? And again, if you wanted to simplify this, you would find that this is a 159.31 times y. I think it would be just fine to leave it like this because you're going to be putting it in a calculator anyway. So we're going to use that objective function again when we get to example 2. But for right now, we're going to learn about, we're going to do another P1, which is this same kind of idea, and you're going to have to try this. And I get that it's tedious, and then we'll move forward with some other stuff. Again, I know that these are tedious problems. Please don't be stressed. You're not going to have to do one like this by hand in the real world. And I'm just fine with you knowing how to find stuff in your calculator if you have to. So let's go ahead and try a P1, same idea as this one. So P1, so for P1, we're going to use the table of statistics that we have, which I put here, right, to basically do the same thing we did in example 1, but with a different farmer and planting different things. So farmer wants to plant corn, which I'm going to call X, and soybeans, which I'm going to call Y, on 150 acres of land. The farmer wants to plant between 40 and 120 acres of corn and no more than 100 acres of soybean, right? So what we're going to do is we're going to start by writing our constraints, right? So we're going to determine the constraints, we're going to graph the feasible region, and then we're going to write the objective function. So those are the three things we're going to do. So the first thing I'm going to do is write my constraints, right? I already assigned corn as X and soybeans as Y. So my first constraint is that X plus Y has to be less than or equal to 150, right? Because that's the total amount of land he has. My second constraint is that the corn, which was X, has to be between 40 and 120 inclusively. And my third constraint was that we have no more than 100 acres of soybeans, but I want to add a caveat to that. You can't have negative. So I'm going to go ahead and throw in that Y has to be bigger than 0 but smaller than 100. So I had to throw this piece in by logic. I didn't have to do that for the X's because the X's were already between two positive numbers, right? But I did that for the Y's. So when I graph this guy, I'm going to graph him as Y is less than or equal to negative X plus 150. Now I'm going to suggest that when you graph this, again, you go by tens, right? Maybe even 20s because the 15 is kind of big, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's not super fun, but cool. So it's up to you. You could go either by 10s or you could go by 12s. If you're going to go by 10s, I'm going to suggest that maybe you inch down a little bit. And again, you're probably doing this on your own graph paper. But if you, we're going to do this. That's 12, 13, 14, 15, because I probably need to go that high. So, so over on this side, right, this is going to be my soybeans. And I'm just going to write soybeans, not soybean acres, because I'm low on space, right? And this is going to be my corn acres. And I'm going to go by tens, right? So we're going to just say, hey, that's 20, 40, 60, 80, 100, 120, 140. And we'll do the same thing on the other side. So we'll just call that 20, and that should be enough. So 40, 60, 80, 100. That gets the gist. Okay, cool. So soybean acres and corn acres, cool. So when I graph this, right, I'm going to start with the, we'll start with this guy first, right? My Y has to be between 0 and 100. Well, here's 0. And I'm actually, it could be equal to 0. You could choose to plant none, so I'll put an equal to there, because you could choose to plant none of something. Like you could say, hey, I'm just not going to plant any soybeans. Maybe it's not worth it for you. And 100. Okay, so that's, and I know that I want to shade in between those, so I'm just going to go ahead and put some big no's on top. I can already know that I'm not going below quadrant 1, which is why I picked a graph that only had quadrant 1, because it wouldn't make sense to have negative things that you plant. In blue, I'll do the X's, right? I need to be between 40, so here's 40, right? I need to be between 40 and 120, which is here. So I can basically put no's outside of that. So anywhere outside of that's going to be a no. So I'm shading somewhere in that middle. In green, I'm going to go ahead and put this guy, right? So the thing about this is it starts at 150 here, and it's going to end down here at 150 down here, which is hard to see, but it's going to end, since this has a slope of -1, right? Down 1, right 1, down 1, right 1. Basically, you could just cheat and go down 115, right? So down 1, right 1, down 1, right 1, sorry. Down 1, right 1. Here we go. So you can either do this, or if you're in a situation where you have like a straight edge or something that's easier to deal with, you could just realize that you're starting at 15 on the y-axis and you're going to connect the dot to 15 on the x-axis, and that would also be fine. Okay, and this says less than, so I'm not going to shade anywhere above it. So it looks to me like when all is said and done, my feasible region ends up being this spot here. Now notice there are 4 sides. Oh, actually, there's 5 sides. I lied. There's 5 because, so what I want you to notice is that up here, this is actually 1 unit wide, right? Because like if this had been in the right spot, if I did a better job, there are 2 corners here. There's one here there's one here, there's one here, one here, and one here, right? So that's my feasible region in black. Those are the corners of my feasible region. And we're going to talk about why those corners matter in a little bit. And you could find those corners basically by finding where the different graphs intersect, right? Like this is where x is 40 and y is 0, right? So this is so this is 40 comma 0, right? And this is at 40 comma 100, right? So this dot would be 40 comma 100. This dot was at 120 comma 0, right? And then these two dots are the ones that are slightly harder to find because these are the ones where you actually have to use the line that has two variables, right? But this is the spot where y is 100, right? So you know it's blank comma 100, and it's on the line x plus y is 150. So this is the spot 50 comma 100. And by the same token, this spot is where x is 120, right? And it's on the line where x plus y is 150. So that must be 30, right? So that's that corner. So there are your 5 corners, right? So it's worth noting, it's going to matter later what those corners are. So when we get to the next example, we're going to care what those corners are. And the corners were 40 comma 0, 40 comma 100, 50 comma 100, 120 comma 30, and 120 comma 0. Okay, so those are going to matter later. We just don't know that yet. Okay, so then the last part, so we did the constraints, right? We graphed the feasible region. And then the last thing we're going to have to do is write the objective function. And sometimes the objective function is going to be given to you, but here it's not, so we're just going to go ahead and write it. So let's go ahead and erase some of this stuff so that we can write our objective function. Okay, so our objective function is basically going to be the same thing that we did at the end of example 1, right? I'm going to use R for revenue. So I'm going to say, let's let R equal revenue, right? And again, if you remember what we did last time, you could actually kind of cheat and say, wait a second, I get it. My R in terms of x and y is the number of bushels times the amount per bushel. So the 315 times the 113.5 x plus the 680 times the 34.9 y. And one of the things to notice here, and this is the reason that if you're a farmer, you have to pay attention to this kind of stuff, is that you'll notice that you get a lot more money for planting soybeans, but you also get a lot less yield on those crops, right? So you're going to have to figure out the right balance to try and meet all of those goals, right? And again, different crops require different water, require different amounts of nutrition, right? Require different amounts of care. So some crops are more worth it because they're easier to maintain, and not only might they have a high yield, right? High yield per acre, but they might also be easier to maintain than others. Okay, so let's call it on P1 and E1 for this video. In the next video, we're going to talk about why I told you that those corners mattered. Because again, I know this is a little bit of a tedious section, but I promise we'll get through it together, and you're not going to do linear programming by hand after you get through my class. I promise.